Assalamualaikum. Good morning, everyone.
Morning, Doctor.
Morning, Doctor.
Hari Raya. Okay, I hope you guys are ready to resume our lecture. Okay, we're going to continue with LU3, right? Okay, so we are done with LU1 and LU2, and you have covered that as well in the mid-semester exam. So now we're going to focus on the last LU, but it's going to be a few lectures under LU3, right? Okay, so we're going to start with the first lecture of LU3 today. All right, I'll show the QR code at the end of the class, yeah, for those who haven't scanned. Okay. Hold on, yeah. Right. Okay, so previously we talked about non-parametric tests, because we are dealing with non-parametric data. So LU3 is about parametric tests, whereby these tests are designed for analyzing parametric data. Okay, so before this, I always emphasize what is non-parametric data, right? So non-parametric data, it can be those data that are less than, small in number, less than 25, but also it can be of category, what's the two things? Nominal and another one? Right. The type of non-parametric data. One more type. Nominal and
Ordinal.
ordinal. Yes, correct. So that data, if let's say, even though if let's say, okay, there are two possibilities. If let's say the data are ordinal and nominal, but they are maybe more than 25, they have to be analyzed using non-parametric tests. But if let's say the data are not nominal or ordinal, but they are less than 25, they are still classified as non-parametric data. And for that reason, we have to analyze using non-parametric tests. Okay, so parametric data are those that are first, it can be more than, the number can be more, yeah, the data can be more, or big size of data. And another one is it can be, the distribution can be assumed. Yeah? We can assume the distribution based on certain types of distribution. Okay, that is parametric data. Okay, so we are going to see how we're going to analyze parametric data. So LU3, we are going to cover a few types of tests, yeah, which are designed for analyzing parametric data. Okay, so first let's have a look at probability distribution. Okay, probability distribution. So under this lecture, this is the first lecture, we are going to cover what is observed distribution and what is standard distribution. And under standard distribution, there are two types of distribution. The first one is discrete distribution, and another one is we will cover in the second lecture after this. Okay, the second one is, it's just right here just for you to take note. Yeah, continuous distribution. Okay. So standard distribution can be, discrete distribution can, standard distribution can be divided into discrete and continuous. Okay, but before that, here we talk about probability distribution. I hope you guys know what is probability. What is probability?
The chance of something to occur.
Yes, the chance of something to occur, yes. Or in Malay, we call it kebarangkalian. Yeah, kebarangkalian. So if you have, let's say, if the outcomes are maybe, what? If let's say you attend an interview, the probability to be accepted or the probability of not to be accepted, there are two outcomes, right? You can be accepted, you can be not accepted, right? So you have 50% of chance or 50% of probability to be accepted and 50% of chance or probability not to be accepted. Okay, so that's the probability. Yeah, the chance of the event, chance of the event to occur. Okay, so kebarangkalian, yeah. Right, so let's have a look at what is observed distribution. So when we say distribution, distribution is like how certain types of data looks like the whole data, the overall overview of the data. Okay, so normally when we have data, we normally view it as something that has a shape. Nah? When we say distribution of, let's say, 60 data, yeah, that's the sample size. But when we want to plot the whole view of the data, it can be something like, something that is like bell curve, yeah, or maybe something like this, or something like this. It depends on the data, okay? But the whole thing here, this is what we call distribution, okay? Distribution means like the overview of the whole data. Okay. So distribution, it can be categorized as observed distribution and standard distribution. So observed distribution, as the word or the term implies, it's something that we observe, something that we don't do anything, or we don't actually, we don't do any sort of standardization. Okay, when we say standard distribution, on the other hand, is something that when we generate, how to say that, we refer something in order to get some sort of, how to say that, interpretation. Okay, like for example, we use table. Like before this, you also refer some of the tables, right? So that kind of tables, that is the things that have been created by statisticians in the past. So that kind of things are what we call standard. Yeah, when we refer to what kind of table before, right? We have all the non-parametric tests, right? So those values are standardized. When we refer to, for example, certain type of table, like the values are there, you cannot change it, it's standardized. But when we say observed distribution, it's something distribution based on whatever the data are. Okay, right. So I hope you can differentiate. So okay, so right. So when we talk about standard distribution, there are two types of distribution. It can be classified into two types, namely discrete distribution and also continuous distribution. Okay, so the difference lies in the term here, discrete and continuous. So what discrete means? Discrete data or discrete values refer to whole numbers, like there is no decimal points. I think I've discussed about this before. Like when we say discrete is something that is the number of person. There are 5, 6, 7. The whole, that number is called whole number. There's no like 1.5 people person. There's no such thing, right? We never say 1.5 girl, 1.7 girl. There's no such thing. So we say 1 girl, 2 girls. Yeah. So that number is whole number. So the easiest way for you to remember is without decimal points. That is whole numbers. So that kind of data, if let's say we have number of students who participate in the quiz, for example, that is discrete data. That kind of data is called discrete data because it refers to the number of people. We know that there is no decimal points for the number of people. So that kind of data is discrete data. So the distribution of the data for that particular data is discrete distribution. Okay. So when we say continuous distribution, is the other way around. It's continue. It refers to the continuous data or continuous values, numbers. Yeah. For example, if we want to say the weight of students in class A, for example. So we know that the weight, there are 0.5, 0.3, there are decimal points. So that sort of data is continuous. Yeah. For example, 50.1, 50.2, 50. Even like 50.15, 16, 17. Yeah, it's like there is infinite values of the data. So that kind of data are continuous data. And if let's say we want to analyze it, we have to, the whole data, we call it continuous distribution. Okay. So under discrete distribution, we are going to cover binomial distribution and Poisson distribution. And for the continuous distribution, the tests, the tests under continuous distribution are normal distribution and t-distribution. Okay, so we are going to cover binomial and Poisson first. Okay, so observed distribution. Okay, still. Yeah, observed distribution is just not that really much. Okay, so first let's have a look at observed distribution. Okay, as I said just now, observed distribution is distribution that we observe. We just observe and we don't do any standardization. We don't refer to any table. We don't refer to any normally it's table or tables. So observed distribution is anything that we just observe. Yeah, is derived from the data collected. Distribution is peculiar to that one situation, unique. Yeah. So if let's say you have one situation, it will give you that sort of data. If you go to another situation or another measurement, you will have another set of data. So that's peculiar. Yeah? The numbers collected are all measurement of a variable which varies when observation are made of it. Yeah. So it can be varied from one situation to another. To make sense of all the data collected, first sort the data. Okay, so this is what you will do when you collect the data. Then what you have to do with the data, you have to arrange it, before you analyze it, from the lowest to the highest maybe, and maybe you arrange it in a table. Yeah, that's something to do with organization of the data once you collect it. So that's what is meant by the second statement here. And how you arrange or organize the data, you can use various kinds of ways. Okay, we can plot it. We can create a table, right? We can plot it using histogram, frequency histogram, right? And we can also have a probability histogram. Okay? There are different types of histogram, but basically histogram is something like something that shows you, like, I hope you know what histogram is, right? Something like this, yeah? So it shows you the distribution, how the overall data looks like, okay? Okay, probability histogram. Okay, so when we say probability histogram, is something to do with the probability. So we have to calculate probability and create a histogram based on the probability values that we calculate. And the formula for probability is given by this. Yeah? The probability of anything that happens or an event is equal to the frequency of that particular thing divided by the total frequency or the total data. Yeah. The frequency for a range covering several classes can be calculated by adding the probabilities of the individual classes. Okay, I'll cover that after this. Cumulative frequency diagram, which is also called OGIF. Okay, there is another type of way how we can present the data. So OGIF is another way. This one is actually, it looks like something with a curve instead of like, it's actually, you can also plot the OGIF based on the histograms, something like this, but there is a curve. So that's the difference. Yeah. Okay, so let's have a look at the next slide. Okay, so whenever you have collected the data, what we have to do is like, this is basically the first thing that you have to do. Like, you have to organize your data, right? Organize your data and identify the frequency. Let's say, you know, this is about what the length of line. Okay, this is the classes, call it, yeah, classes. And this is frequency. Frequency is like the number of the things or the event occurs or happens. Yeah. For example, if frequency 1 means like the data of is from 0 to 9 is 1. Yeah. And so on. Okay. So it's the number of how many times it happened. Okay. Here is the total frequency or the total frequency, yes. So when you add up all the things, yeah, of the data, this is what we call total frequency. Total frequency, okay, 40. Now that is the basic data that you have, or we call it like the raw data, the raw data or primary data. So whatever that you get from your measurement. Okay, so when we say statistics, statistics is not just presenting the raw data, but we also present what we call secondary data, or something that gives a meaning to the primary data. Okay, so this is actually what the statistical analysis is all about. I mean, it's part of it. So when you start counting, like perhaps how much is the probability, so this is what we call the data that we derive from the primary or the raw data. Okay, so this is what we call secondary data. Secondary data, and in this case, it's probability. It's not always probability. It's not that probability is the only secondary data, but this is an example of it. Okay, but if let's say you calculate the mean, you calculate the standard deviation, that kind of data is also called secondary data, because it's something that comes from the raw data, yeah, the analysis. Okay, so I hope you understand. So in this case, the secondary data is a probability. Okay, so how you calculate the probability is based on the raw data, right? Right. For example, for this class 0 to 9, how you get 2.5 is 1/40 times 100%. You get it in terms of percentage, right? 2.5. But if you convert it into decimal points, you will get 0.025. 0.025. Yeah. And the total probability in the decimal point is 1, or the percentage is 100%. Okay. Right. So each of this is the probability of the classes, each of the classes here. Okay. Right. And that is individual probability. But if let's say you want to find what is the probability, for example, if you see the example, the B, number A is straightforward, is individual. Yeah, the probability of the line between 20 to 29. So you just get it directly from what you calculate here, right? 10 divided by 40, sorry, 4 divided by 40 is 10%, or 0.1, this one, right? But if you want to calculate the probability involving different classes, yeah, for example, from 20 to 49, yeah, 20 to 49, it refers to this one, isn't it? Right? So you have to consider all these values. So you have to add up all those values, 0.1 plus 0.25 plus 0.4. So the answer is 0.75. So that is the probability of the event or the measurement from 20 to 49. Okay. All right. So this is observed distribution. We don't do anything. We don't refer to any table. We just analyze the things as it is from the data itself. Okay. We are still in observed distribution. Okay. So this is another way how we want to present the data, right? So just now here, if you see each of the probability here, we calculate the individual probability of every class, right? Like for example, 2.5 is the probability of from 0 to 9 and until 60 to 69, which is 2.5. Yeah, so that is the individual probability. This one is individual probability. Okay. Now, let's have a look at the second type of presentation, where it is called cumulative less than. Okay. So the difference here is, if you see the class, if you see this is the classes, right? This is the classes. So there is no 0 to 9 or what else before this? 0 to 9, 10 to 19. So it doesn't have the range anymore. But what it is presented here is the values of less than 9, less than or equal to 19, less or equal to 29 until 69. Okay. And how it affects the probability. So it will be accumulated actually. Like for example, the first one, it doesn't have any difference because that's the first probability, which is 0.025, yeah, right? But when it comes to the second class, yeah, so it has to consider the first class because by definition here is anything that is less or equal to 19. So it means that it will also covers the first class, yeah, which is 0 to 9, isn't it? So that's why if you see the values over here, which is 0.075, it is actually the summation of this thing, the summation of this one, yeah, 0.025 plus 0.05. Okay, so that makes 0.075. Okay, I hope that's clear for you, and so on. Okay, so you have to add up the values before that because, you know, because of this, the difference of these classes. Yeah? Okay, so and how you want to make sure that what you add up is correct. Your total value here, the final value should be 1. If you got 1 point something, so there must be something wrong in the calculation because the total should be, at the end should be 100%, okay? Or 1 in the decimal point. So if you got 1.3, 1.2, there's something wrong that you have to find out in the middle of your calculation, okay? So this is cumulative less than, we call it cumulative less than. So another type of presentation is what we call cumulative more than. Yeah, it's opposite. So just now you see that the values of the symbol used here is less, but here is more than. Okay, so and it is actually opposite as well. I mean, in terms of the probability, it starts with 100% because anything more than 0 in this case, it covers everything. So it should be 100%. Huh? So this one should be 1, okay? And then more than 10, okay, more than 10. So if you want to refer to the original data, more than 10, it means is actually why it is opposite. Yeah. So more than zero is everything, right? So it means everything. I hope you can follow me what I'm saying here. Okay, if it is just now more than 10, is it? Yeah, more than 10. So it means it covers everything here, 10 and above. And of course until 69. Yeah, so it covers everything. So that's why if you see back this one, right? So it covers everything. It means this is the value. Yeah, 0.975. Yeah. Okay, go back to the original difference. It means that you add up all this stuff from 0.05 until 0.025. You add up. So it gives you 0.975. Okay. Right. So here it becomes less because at the end dia akan refer back to the last class, yeah, which is the last class here, which is 0.025. Okay. Right. If you see back here, the last class here is 0.025, right? So that is how cumulative more than looks like. Okay, it starts with 100% and it ends with the individual probability of the last class, which is 2.5. Okay, right? I don't bring my pencils. I have to use my finger to write these things, so it's a bit like not convenient for me. Okay, so any question for this? This is observed distribution. Yeah, you can see that we don't refer to any table, any whatsoever table. We don't have any table. We just calculate as it is. So the distribution is called observed distribution. Yeah. Right. I have an activity for you. Okay. Wait. Helena? Okay, wait. Okay, we continue first because I think I need to adjust something with the older system. Okay. So that is observed distribution. Observed distribution. The second part is standard distributions. Okay, standard distribution, as the name implies, the standard, it refers to something or a standard that is prepared in order for us to interpret the distribution. Okay. Standard distribution implies that the distribution resembles closely a theoretical situation for which the distribution has been constructed mathematically. Okay, so basically in this kind of distribution or test, we are going to refer to a table whereby we get the values there in order to find the probability. Yeah, basically that's how it looks like. Okay. So the standard distribution can be divided into two types: discrete distribution and continuous distribution. Okay, discrete distribution and continuous distribution. Okay, I've mentioned just now what's the difference between discrete and continuous. Discrete whole number, continuous are continuous values or data. Okay. So under discrete distribution, there are two types of tests or two types of distribution: binomial and Poisson. And for continuous, there are normal and t distribution. Okay, normal and t distribution. Okay, so one of the earliest standard distribution to be developed was the binomial distribution, and the most used or the best known standard distribution is the normal distribution. Okay, so that's just some information about it. Binomial is the earliest one. Normal distribution, I hope you know what normal distribution. It looks like something like this, or bell shape we call it. It's something that, you know, it's like a bell shape, and normally here is the mean. The mean. Okay, right. So that is normal distribution. Okay, let's have a look at what is discrete distribution first. We refer to binomial first. Binomial distribution. Constructed mathematically, means that it's based on standard, basically. That's why it's under standard distribution. Distribution is discrete, variables are distinct, giving rise to stepped shapes. Okay, discrete means whole number. Remember, discrete means whole number. Okay, so it means that no decimal points. So when we talk about distribution can be in various shapes. For example, this is the shape of the distribution, we call it. So the normal one is like this. This is symmetric, means that it is evenly distributed, like it's like equally, it's equal. But we also have some distributions that doesn't looks like symmetric, but instead it looks like something either right skewed or left skewed. Okay, this is right skewed, we call it. So where the mean is close to zero. So this is like 0, and this is actually we call it 1, because when we talk about probability is from 0 to 1. Okay, so this is right skewed, and left skewed is when this is normally the mean. When the mean is approaching or near to 1. So this is 0. Okay, so that's the examples of the distribution, the types or the form of distribution. Okay, binomial situation can be recognized by the following characteristics. Okay, so why it is called binomial? Binomial means the word bi is 2. It means there are two outcomes. Two outcomes. So we call it P and 1 minus P. So there are two outcomes. So that's why it's called bi. So we normally name the first condition or the first situation as P, right? If let's say we have in a situation where we want to have success and failure. Okay, so the success is denoted as P, and the failure is 1 minus P. Okay, why 1 is because the total probability is 100%. So if let's say you have 50-50, right? 50% success. Of course, another one, it should be 100 minus 50, isn't it? Because the percentage, the total percentage is 100%. So 100 minus 50, or if you want to convert it into decimal points, is 1 minus 50, or 1 minus P, because P is 50. Okay. So that's how it is is denoted. P and 1 minus P. Okay, P is the event, is the probability of the event. Whatever the things that you are referring. So it's not only here, it's not only success or failure, it can be any situation or any outcomes, whenever there are two outcomes. Okay, so in what situation the binomial distribution or binomial test is used? So when there are two things, two outcomes, cell or no cell, yes or no, success, failure, with flowers or without flowers. Anything with two outcomes, you can analyze it using binomial distribution as long as they are parametric data. Okay, and you have to also differentiate between parametric and non-parametric. Okay, so how we calculate the probability under binomial distribution. So this is the formula. Yeah, this is the formula. It will be given in the exam, but you have to know how to use it. What NCR means, what R refers to, what P it refers to. So you have to know by yourself. Right. N is the sample size. P is the proportion of type 1 in population, the probability of event 1, the event, right? And then 1 minus P is the P is normally given in the problem. 1 minus P, okay. NCR refers to what NCR means. It means that NCR, it refers to n factorial divided by n factorial multiply n, sorry, this one is R, okay. R, n minus R in bracket factorial. Okay, so this exclamation marks, this one, we call it factorial. Remember? I think you have studied this somewhere before. Factorial. It's called factorial. Okay. So what does factorial means? If let's say we have 5 factorial, it means it is equal to 5 times 4 times 3 times 2 times 1 until 1. So that's what it means here. N factorial refers to n multiplied by n minus 1, n minus 2 until you reach 1. Yeah? Okay? So 5 factorial, 5, n. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. And so on until you get 1. Okay? That's what factorial means. So if we have 6 factorial, then you have to start with 6n until it reach 1. Okay, so that is what factorial means. Okay, so basically, what you have to find out is what is the value of this thing that will give you the probability. Okay, so here, whatever the distribution, like now we start with the binomial distribution, but we are talking about probability. Yeah, this topic is about probability. What is the probability of whatever the things, whatever the situation that we are analyzing. Okay, so here we are actually, this is referring to probability. Yeah, at the end you are calculating probability. Right, so let's have a look at one example, yeah, under this binomial distribution. From past records, the probability that a machine will need correcting adjustment during a day production run is 0.2. If there are 6 of these machines running on a particular day, find the probability that no machine needs correcting, just one machine, exactly 2 machines, and more than 2 machines need correcting. Okay, there are a few questions over here. But let's have a look at the question first. Let's analyze the question. So here, the probability that a machine will need correcting is 0.2. So we denote P as 0.2, right? And of course, here we know that 1 minus P will be 1 minus 0.2, that's 0.8. Yeah? Or, yeah, I mean, the event of not, the event that doesn't need the adjustment. Yeah, the probability of doesn't need the adjustment is 0.8. So if there are 6 of these machines running on a particular day, find the probability that no machines need correcting. Okay, what does this 6 means? This 6 is n. Okay, so there are 6 machines, right? So how we want to analyze this problem? Okay, so let's have a look at the solution. So we apply this formula. Yeah, this formula is to find the probability. Yeah, right. And then the R is 0.2. Sorry, is it the R? No, the R. No, not the R. The P is 0.2. Okay, we have identified that. N is equal to 6. Okay, so what does R means? R is the event that you are analyzing. Yeah? For example, in the first question, no machine meets correcting. So the R is 0. In this case, R is 0. Okay, so that's how you substitute the values. So you know what is N, so it should be written as 6CO, right? Okay, if you refer to the solution over here, right? 6CO, because we have substituted the values. P is 0.2 to the power of R. R is 0. 1 minus 0.2 to the power of N minus R. N is 6. R is 0. So we got like 6, right? So at the end, you get 0.8 to the power of 6. Or the value is 0.2621. Okay? So that is the probability. So basically, this is the probability that no machine needs correcting. That's what it means. So it means that if you convert it into percentage, it's 26% of chance that the machine doesn't need correcting. Okay. So another thing that you have to you can take note is that the values over here, whatever the things that you calculate, it is in the form of decimal points, it should be less than 1. It should be less than 1, or it should be more than 0 to, it should range from 0 to 1. You cannot get it negative, you cannot get it more than 1. Okay, if you get it negative, there is something wrong with your calculation. And same as well, if you get it more than 1, there is something wrong with your calculation. Yeah, that is the rule of thumb, because the total probability is 100%, or is 1, if you convert it into decimal points. Right. So the second question, just one machine needs correcting. So now the R is 1. The R is 1. So you just substitute the value of R equal to 1 into the formula. So you got different values, right, here. So that's how you got it, and you got the values of 0.3932. Okay, what is NCR, NC1, and NC1 means, n factorial, R, okay, 1 factorial, n minus R, which is 6 minus n minus R, 5 factorial. So you have to actually solve this thing by yourself. If let's say you are doing it, if you are calculating it manually like that, okay, after this I'll introduce you the table, okay, but that's how, you have to solve it, you have to know how to solve it, so this one, it means 6 times 5 times until 1, and you have to elaborate each of the term and find the value of it. I hope you know how to do this. Have you studied factorial before, guys? Yes? Have you?
Some time ago.
Some time ago? I remember that I studied that during my additional maths class. Right, see, Form 5, yes. So I still remember. You should remember more, in Ed Maths, yes, correct. Okay, you should remember more than me, because I've left school some time ago already. Okay, so that's how, you have to solve it, how to solve the factorial. That's how you solve the term NC1, or whatever the NCR in the formula, okay? Okay, no, don't worry. This is just a revision. You will revise many things, whatever that you have learned in your high school, and you can always revise later. Okay, so that's factorial. I hope you remember or revise back later. Okay, so the answer here is 0.3932 for the second question. Okay. And for the third question, exactly 2 machines need correcting. So now you just replace the R with 2. Yeah. So R is the number of event. Remember, R is the event that you are analyzing. Yeah. So in this case, it is R that is changing. So that's why you get different values of probability. Right. So let's have a look at the fourth question. More than 2 machines need correcting. Okay, here there is a trick over here. You can solve, of course you can solve like it means more than 2. It means it doesn't involve 2. If it involves 2, it will mention that 2 will be included, 2 and at least 2, something like that. But now when it says that more than 2, so it means 3, 4, 5, and 6, because now here the n is 6. Yeah. You can find you can solve this problem by finding r equal to 3 plus r equal to 4 plus r equal to 5 plus r equal to 6, isn't it? Yeah. But you can also solve it as, since you have solved in the previous question 0, 1, and 2, you can also solve it as 1 minus p 0 plus p1 plus p2. 1 minus the sum of the probability of p0, p1, p2. Okay, there are 2 ways how to solve it. And since that in this case you have solved probability of 0, 1, and 2, which is given by A, B, and C, so you can just substitute the values 0.2621 plus 0.3932 plus 0.2458, and then the sum of it you minus, you subtract from 1. Okay, this one. Okay, and you will get these values, 0.0989. Okay, make sense? Because it's something that is, when we say, because we know that it's 6 and it's 3, 4, 5, and 6, of course it will be 1 minus the thing that is not included, right? Which is 0, 1, and 2. Yeah. So that's how you got 0.0989. Yeah. Okay. Any questions so far? Clear? The key thing is that you have to use this formula. NCR, PR, Y minus P, N minus R. So you have to know what is P, what is R, what is N. R is the event that you are analyzing. P is the probability of the event. Normally it's given, yeah, it's given in the question, but you have to identify it. Okay, so this is how you calculate or solve manually. When I say manually, because we have to calculate the n factorial and so on. So another way how to solve the binomial probability is by using table. Yeah, by using table. So that's why this one is under standard distribution. Yeah? We can refer to a table. Okay. So if let's say you want to solve, if let's say I want to use table and I don't want to use the manual calculation, yeah, instead of using the formula just now, I want to use table. So if let's say I want to answer the first question, no machines need correcting. Okay, no machines need correcting. The information is still the same. R is 0, N is 6, and P is 0.2, right? 0.2. Okay, so if let's say I want to find what is the P when R equal to 0, okay, so how I'm going to analyze it, if let's say I want to get it from the table directly, which is actually much faster. So this is the binomial distribution table. It's actually the same table that we used for sign tests last time. Yeah, the same table. But how you refer it is a bit different, because now we know that we have the p-value. Yeah? So let's say in our case just now n is 6. R is, okay, so we have a column n, the first column, the second column is R, and the third big column here is P. Okay, so P equal to 0.2, you refer to these values. Okay, and this is n, this is 6, right? And we refer to 0 for R is equal to here, 2.2621. Yeah. So if we want to refer back to, we want to compare our results with the manual calculation, is the same, right? 0.2621, yeah, for A. So that's how you get it. It's quite straightforward. Yeah? But just now I want to introduce you the formula. So this is another way how you can solve the binomial probability, binomial distribution. And the same thing for the rest. If let's say you use R equal to 1, is equal to 3932, right? Okay, so if you want to compare with our answer for B when we calculate manually, is this one, isn't it? 0.3932. C is 2458. So this one is here, 0.2458. Okay. But if let's say you want to solve, like for example, question D, right? D, that one you have to take note of the values that, for example, if let's say what is P0, P1, you have to write it lah. Yeah? You cannot just get it from the table. So you get the value for the P0, P1, P2, and then you have to subtract the whole sum from 1. Like, I mean, if you use this formula. If you use this formula, yeah? If you use, okay, if you use this formula, this formula, okay, but you can get the values P0, P1, P2 from the table. Or if you want to solve using R equal to 3, R equal to 4, R equal to 5, R equal to 6, also can. You get it from the table. Okay, this is binomial table. Yeah, binomial table. Okay. Two parameters affect the skewness of the distribution. Okay. So means that the distribution, it depends on, what does it mean here? It refers to the n, and it refers to the probability p. Okay, that's what it means. The skewness. The skewness means like how, whether it's skewed to the right or to the left, or whether it's symmetric. Okay, or in short, the distribution, it depends on the n and also the probability of the event. Yeah. Distribution having different parameters while displaying the same characteristics will be different. Yeah, of course, every distribution, it will have its own shape or behavior. It's not the same with others. Distribution having the same A and P will be identical. Right skewed shapes occur when P is small, which is close to 0. So what does it mean? It's like this. Yeah. So the P value is small. That's why it's skewed to the, this is right skewed. Yeah? And when it is left skewed, it's something like here. When this is 0, this is 1, this is 0, this is 1. Yeah? When P is large, it's close to 1. So it's skewed to the left. Yeah? Symmetrical shapes occur when P is 0.5 and when N is large. Okay. So this one, symmetric, is when it is here. Okay. When it is equally distributed, actually. Yeah, 50-50. When N is large. Another behavior that contribute to the normal distribution is when the n is large. This one is very apparent for many cases. For example, if let's say we want to talk about the grades, the students' grades. This is what we always observe at the end of the semester when we analyze the results of the students. Whenever the size of the students increase, at the end, the distribution will look like a bell shape, a normal curve. Yeah. So let's say here is, for example, like this one. When we say about student grades, this one is like when people got A lah. The lowest is here is what, F. Let's say. So there's quite just a few people will get A, a few people will get F or D, D, and at the average of the students will get in the middle, like B. Is something that is always happen, okay? And it's not just about the grade, but also if we talk about whatever the things that you measure, the height of students. Not many people will be, like will have extraordinary height. Yeah? So the average will lie in the middle. So that's always, it's something that it occurs in many situations, the normal distribution or the symmetrical shape. So it's something very interesting to analyze. One of them is student's grade. Okay, so that's Poisson that's binomial distribution. Okay, so the second type of discrete distribution is Poisson distribution. Okay, so what's the difference between binomial and Poisson? Binomial is when the n is less than 20, when the n is small. N is the size of the data, and when the n is greater than 20, we use Poisson distribution. Yeah, Poisson distribution. And under Poisson distribution, there is formula, or there is also a table, Poisson table. Okay. But before that, let's have a look at some of the information over here. Is the discrete distribution. It gives better approximation when n is greater than or equal to 20. It describes the occurrence of isolated events with a continuum, or accidents over a given period of time. Right? It's similar to binomial but with an infinite sample size. Okay. The sample population has two elements. Yeah, the same thing like binomial still, p and 1 minus p. Yeah, two outcomes actually, two outcomes. So it's actually like a sister of binomial, but it's just like it is used for when n is greater than 20. Yeah. Okay. So the same thing. The distribution, it can be symmetric, it can be skewed to the right or to the left. Yeah. So this is the formula for the Poisson distribution that you have to take note. Okay. So the E is a constant. If you refer to your calculator, there is E, right? Yeah, you have to identify from your calculator what is E, because you're going to use it for calculating the distribution under Poisson. So E is a constant. It's equal to 2.718 if you want to translate it into constant value. Okay, alpha, not alpha, lambda. Lambda is this symbol. This symbol is lambda, we call it. And it refers to the average number of events, or mean value. Okay. Okay, R is the events, whatever the events that you are analyzing. Still the same definition with the binomial. R is the event that you are analyzing. So the formula looks simple. E to the power of minus lambda multiplied by lambda to the power of r divided by r factorial. Okay. And same as binomial, we can solve the Poisson distribution. We can solve the Poisson probability using this formula or using Poisson table. Okay. Now let's have a look at how to solve using this formula. Okay. So given to you this problem, The safety of a dangerous intersection was being investigated. Past police reports indicate a mean of 3 accidents per month happen at this intersection. The number of accidents is distributed according to a Poisson distribution. Okay. So let's have a look at the data given. The mean of 3. So this is the values given, right? What else? That's all. Okay, so this mean value is the lambda. Yeah, lambda. Lambda is equal to 3. Okay. So the first question, the highway safety division wants us to calculate the probability in any month of exactly 0, 1, 2, 3, 4, 5 or more accidents happening. Okay, so basically we have to find what's the probability of each of that. Probability of r equal to 0. This is actually referring to r. Yeah, and if you notice, you don't see the information of n. N is not given because n is not needed in the formula. Here, you see here, it's not needed. And also because of this one is Poisson. If you see the definition just now is actually more than 20. It can be this distribution is used for infinite sample size. Yeah, so this information, infinite sample size. So it can be up to, you know, infinite. Infinite means that you cannot, there is no endpoint of it. Okay, so the n is not an important information in Poisson distribution. Okay, so how to solve this problem? So basically you have to find what is the p of 0, p sampai ni lah. Yeah, right. So p, let's have a look at p0. So means that r is 0. So you just have to substitute the value of r into this formula, right? We know that the lambda is 3, right? E to the power of minus 3 multiplied by 3 to the power of 0, because r is 0. 0 factorial is 1. Okay. Another thing about factorial is 0 factorial is equal to 1. And also 1 factorial is also equal to 1. These two values that you should know. 0 factorial is equal to 1. 1 factorial is equal to 1. Okay. Right. So here is 0 factorial. So that's why it's replaced by 1. Yeah. The value is 0.0498. That is the probability when r is equal to 0. Okay. When r equal to 1, you just substitute the r with 1. Then here you got these values and so on. Okay. So this value is obtained when you substitute the r, the different r values. Okay. So if let's say how we want to find what's the p of, let's say the last question over there, p of n or more. Okay, we do not know what's the n, right? We cannot find like we cannot find the probability of r equal to 6, r equal to 7, r to 8, and so on, because we do not know what's the endpoint. So how we want to find it? We subtract whatever that is before 6, right? From 0 to 5, then we subtract that from 1. Yeah, so if you see here, the whole thing here is referring to these values, right? Okay, so because we know that total probability is always equal to 1, so 1 minus all over those things will be equal to the probability of 6 or more in this case. Yeah, so where the value, the final value is given as this one. Okay, right, so that's how you solve it, using the formula, using this Poisson formula. Okay, let's have a look at the second question. Action should be taken if the probability of more than 3 accidents per month exceeds 0.3. Should we act? Okay, so what happened if let's say the p is greater than 0.3, then action will be taken. That's what it means. So what it means here, we have to find first what's the probability of more than 3 accidents. Yeah? More than 3 accidents. So this is the things that we have to find out first, and then second step is to check whether it exceeds or not 0.3. Then okay, let's have a look at what's the probability of more than 3 accidents. Okay, since in this question, in question A, we have calculated the probability of 0, r equal to 0, r equal to 1, r equal to 2, and so on, right, until 5. So we just use that information. We just use that information and subtract from 1. Yeah. So 0 is this one. Wait. This is this is p equal to 0, r equal to 0. Sorry. This is r equal to 1, r equal to 2, and this is r equal to 3. Okay. Wait, more than 3 accidents. More than 3. This one is quite confusing sometimes. It can be included or it can be not included. More than 3 accidents per month. Action would be taken if the probability of more than 3 accidents. Should 3 be included? More than 3. 0.35 to 8 minus. If I were to analyze this statement, the 3 should not be included, isn't it? More than 3. More than 3. So means that, oh yeah, it should be. 3 should be included, yes. More than 3. Wait, I mean in this case, it should be 4, 5, 6, and 7. Yeah, correct. Okay. Yeah, sorry for that. So here is actually you have to consider whatever from 0 to 3, isn't it? Correct? So this one is r equal to 0, r equal to 1, r equal to 2, and this is r equal to 3. And you subtract the whole thing here from 1 because you want to find this probability. Yeah. Okay, so 1 minus the whole thing here, this is the values given. Okay, and go back to the question. If it is more than 0.3, so action will be taken, and the values that you have here is more than 0.3, so means that the action should be taken, right? The answer is that action should be taken to improve the safety of the intersection. Okay, so that's the answer for this one. Okay, that's how you find the Poisson probability using formula. So how you want to use table? Another way how you can solve the Poisson probability is by using Poisson table. Okay, let me show you the full version of the table. Okay, this is the Poisson distribution table. What is given to you is R. You have to know what's the R value, and also the lambda. Yeah, the lambda. So this is the lambda. The whole thing here, and this is the lambda. Okay, so it starts from lambda 0.005, yeah, until what? So you can see that this table is the values up to here, yeah? Up to 3, the lambda. Okay, and the R is given on the first column over here. Okay, so this is Poisson table. So if let's say we want to solve the previous problem, using table. Yeah? So far so good, guys? Okay. Any question? You know what I'm talking, right? Are you guys with me?
Doctor.
Yeah. Okay. So now let's have a look at how we're going to find the probability, the Poisson probability using table. Okay, if not using formula. Okay, let's say we refer to the first the first question, r equal to 0. Okay, we know that the lambda is equal to berapa tadi? Lambda is 3. Lambda is 3. So let's have a look at the table, the Poisson table. Refer to lambda equal to 3 and r equal to 0. Okay, so the value that you should get from here is this one, isn't it? 0.0498. Okay, is it the same with what we calculated over here? Yes, isn't it? This one. Yeah, 0.0498. Yeah, okay, it's the same thing actually. But normally in the exam, you just use the table. You just use the table, okay? But yes. Okay, so r equal to 1. Yeah, if you want to refer back to the table, this is the values, right? 0.1494. Susah tak ada pencil. I have to use my finger. This one, okay, you can see 0.1494. It's the same thing like how you calculate it. Okay, and so on. So the important thing for the Poisson table, you should know the lambda and also the r. Okay, there's no end value. It's infinite distribution. Okay. Right. So that's Poisson. That's Poisson distribution. Okay. That's how you find the probability using Poisson distribution. Okay. Poisson distribution as an approximation of the binomial distribution. For convenience, okay. So actually there are some situations whereby we can approximate the binomial distribution using Poisson distribution. So in what case is that? Is when the n is greater than 20 lah tadi, when I mentioned just now. So okay, so there are two situations. First is when n is greater than 20, and another situation is when p is less or equal to 0.05. Yeah. Yeah. So means that if let's say you are given a problem that doesn't have the information about lambda, you have the n, you have the p, but you don't have the lambda. And if let's say it satisfies with these two situations, these two conditions, the first one here, when n is equal to 20, and either one, or the second situation is when p is less, the value of p or less than or equal to 0.05, then you can actually use Poisson distribution in order to find the probability. That's what it means here. Okay, but how you want to find the lambda? The lambda is not given. You use this formula. Lambda is equal to n times p. Okay. For example, if let's say, yeah, do I have example for this? Okay. For example, this example, so this is the original problem. Okay. Given a binomial distribution with n equal to 28 and p equal to 0.025, use the Poisson approximation to the binomial to find the probability of r greater or equal to 3, r equal to 6, and r equal to 9. Okay, so if you see here, this one, this is n equal to, greater than 20. And the p here is less or equal to 0.5, isn't it? So it satisfies the condition 0.05, sorry, 0.05. So it satisfies the condition, the rule given in this statement. Yeah. So you can approximate that distribution using Poisson. Yeah, using Poisson. So what you have to do first, the first thing that you have to do is you have to find the lambda, because you need the value of lambda for you to refer to the table, right? So that's why you need to calculate this. And how you calculate it? Calculate the lambda is equal to n times p. Yeah. So n is 28, p is 0.025. Then you got this 0.7 lambda. Yeah. And from there you can proceed with Poisson distribution. You can use the table. You can, for example, r equal the first question, r greater or equal to 3. So this one means, how you want to solve that? This one is actually, it means is equal to 1 minus p, r equal to 0, r equal to 1, r equal to 2. Yeah. Okay. So you have to, this one you have to know by yourself. You have to determine by yourself. You cannot get it directly from the table. So from this expression, and only then you solve it. So you know 1, okay, PR equal to 0. So you have to refer to the right column in the table. R equal lambda equal to 0.7. Yeah. So this is the value of lambda, and the r, let's say r equal to 0. So this is the value 0.4966, and then r equal to 1, 3476, and r equal to 2, 0.1217. So that's how you got this expression. Okay, and you solve it and you get the value, this one. That's the value. Okay. So r equal to, for the second question, r equal to 6. That's quite straightforward. You just get directly from the table. This one, right? And okay, the third question, the third question, r equal to 9. So you don't see any value of 9 in the table, but how you want to say it? Okay, here, if you see here, the trend of the probability is actually decreasing, right? From 0.4966, r equal to 0.4966, and when it comes to, when it reached r equal to 7, is actually 0. So actually anything that is more than 7, 8, 9 is actually 0. The probability is 0. So that's why here you can answer it 0, although you cannot find the r equal to 9 in the table. Okay, so that's how you you use the table. Okay, right? What else? Okay, I think that's the first lecture is all about. Do you guys still have energy to continue for the second lecture? Or not? Or this is too much for you? Is it too much?
Okay.
Okay. Tapi panjang
Okay,
juga
okay.
yang. Okay. So why don't we just have 10 minutes break maybe? Yeah. For you to recharge maybe. So we still have another lecture after this, normal distribution, because if we don't cover it today, it's going to be a bit tricky for me to cover, because LU3 has 10 lectures. So we have to cover it today. Okay, 10 minutes break. So I'll see you guys in 10 minutes time. Alright, so we continue. Okay, so the second part of today's lecture is continuous distribution. Okay, so previously we have covered discrete distribution. Yeah, there are two types, binomial and Poisson. And then continuous distribution, there is normal and t-distribution actually, but today we just cover normal distribution. Right, so that's going to be the next lecture. Right, so the outline, we're going to see what is the properties of normal distribution, what is normal distribution, and then what is standard normal distribution, and then the probabilities and percentile determination from the standard normal distribution, and finally approximation of binomial distribution with the normal. Okay, right. I hope that this normal distribution is also a revision for you, so that you know, you are not that really strange with it. I hope that you have learned it somewhere before, and this is just to revise what you forgot maybe. Okay, right. Normal distribution, when we say about normal distribution, as I said just now, is something that refers to bell-shaped distribution. We call it, we also call it bell-shaped curve or bell-shaped distribution. Yeah, so this is how the bell shape looks like. Yeah, bell shape. It can be, you know, the types, the shape can be different, but you can see the general overview is looks like bell. It looks like bell shape. Yeah, it can be the height can be, you know, you can see high. The spread is, this is what we call spread. Yeah, the spread is narrow. It can be wider. Yeah, but overall it's called bell shape. Yeah, it's normal distribution. Normal distribution are a family of distribution that have the same general shape. They are symmetric with scores more concentrated in the middle than in the tails. Okay, remember when we talk about this kind of distribution, this is what we call peak. Yeah, and this is tail. This thing is tail actually. Yeah, this one is what we call tail. Okay, so when we say one tail, it refers to only one tail. If it is said two-sided, it refers to two tails. Okay, right. So what are the things or the important parameters when we talk about normal distribution? There are two things. The first one is mean, and the second one is standard deviation. Okay, so what is mean? Mean is actually, it refers to the peak. This is the mean. Yeah. For example, if I say, you know, like, it's like the values in the middle. Yeah. So the mean of the grade, the student's grade, maybe 70. Yeah? So it stays here. This is the mean, and the rest is like whatever. I mean, it covers, of course, the whole thing here. It covers the whole data. But yeah, the mean is the middle value, the average. I hope you understand the mean value, yeah? The concept of mean. And standard deviation is the one that that determines the spread. Yeah? This thing is what we call, for example, here. This one is what we call how wide or how narrow the shape or the distribution. This is what we call spread. Spread. Yeah? How spread? Yeah? How spread? You know, the spread. So what determines whether it has you know, this narrow spread or wide spread is the standard deviation. It's the standard deviation that determines the spread, the width of the curve. Okay. So what is standard deviation? What is standard deviation? If you want to say, like, if I give you a very simple example, yeah, maybe I have replicates three values. Yeah, let's say 70, 71, 72. Okay, and then of course the mean value is 71, isn't it? The mean is 71. So what is the standard deviation? Like, this one is a very simple, you can actually calculate from here. Of course, there is a formula for standard deviation. If you go to Excel, there is a formula, and you also have studied that in previous lectures, right? So the standard deviation is the difference between the mean value and the other values of the data. For example, here 70, right? 70 and 71 is the deviation. The difference is 1. 71 and 72 is 1. So you can actually say that the standard deviation is 1. isn't it? So normally when we express it, the mean value 71, if you see the values plus minus 1, this one is actually the standard deviation. It shows like how much the deviation of the mean value from the data, from the lowest data and to the highest data. Okay, like from 71 with 70, 71 with 72. Okay, this is just a simple one. But if you have like big number of data, then it refers to, you have to calculate it properly lah. Yeah? But this is what standard deviation is. Yeah, the spread. It shows the spread. If let's say you have the number of the standard deviation, if let's say you have 71 plus, instead of 1, you have let's say 5, yeah, it means that, you know, the spread is going to be bigger. It means actually your data is 71 minus 5 is how much? 66. It's actually from 66 to 71 plus 5, 76. Yeah, 66 to 76. That is the range of the data. Instead of, if let's say you just have 71 plus minus 1, is actually your data is from 70 to 72. Yeah? So that shows that the distribution, or I mean the spread is going to be very narrow, isn't it? So that's why standard deviation, it determines the spread of the data. Right. Okay. Normal distribution is the most used statistical distribution. Okay, this because normally is the most common actually. Yeah, it's the most common because it matches many situations more than any other distribution. Yeah, that's why it's, yeah. So it doesn't, this statement is actually based on many observations, and it is actually quite true. It's quite true, although in some cases it might not be true, because in some cases you might not see the distribution looks like the normal, but in most cases I can say maybe about 70% of the situations the distribution of the data looks like a bell shape actually. Yeah, so I would say that this statement is about 70% true. Okay, but to say that it's more common than any other distributions. The principal reasons are: normality arises naturally in many physical, biological, and social measurement situations. Normality is important in statistical inference. Yeah, so because in anything actually, the average values is always something that is in the middle. It's something that is in the middle. Yeah? Not many people has too high height, yeah, or too extreme height, or too extreme too short height. What I mean, let's say if they're talking about height, I mean most of the people have in between. Yeah, so this is actually referring to the average. Yeah, so in anything, the nature of whatever the behaviors is something that is like, it looks like the normal distribution. Yeah, the bell-shaped curve. Okay, right. Yeah, I think I've covered this. Yeah, two important parameters: mean and standard deviation. Okay, yeah, I've mentioned about this one as well. Just all right. The mu is the mean is the peak value. Yeah, it determines the peak value. So this is actually referring to the mean. Okay, this spread is determined by the standard deviation. Okay. The equation for symmetric and bell-shaped distribution, I think this equation is not that really important. You might not use that. Okay, let's skip that. Okay, so we know normal distribution, yeah, but when we say standard normal distribution, okay, whenever anything with standard, the word standard, it is something that has been corrected, not to say corrected, it has been modified based on something. Okay, that is what I can say standard. So that's why when we say standard distribution, we refer to tables. There are tables to refer. Instead, in comparison to observed distribution. Observed distribution doesn't depends on any tables, right? So when we say standard normal distribution, what is the difference between standard normal distribution and normal distribution alone? Okay, so standard normal distribution is when there is a correction that has been done on the normal distribution, making the whole distribution lies with the middle value as 0 here, like the peak value as 0. Yeah, right. So this is an example of standard distribution, standard normal distribution. Okay, so just now if you just talk about normal distribution, any normal distribution, the values of the mean, I mean the middle value or the peak value, it can be any other values. It can be maybe 10. It can be any other values. Yeah, but when we say standard normal distribution, the peak has been, I mean, there is a formula, I mean, applied in order to make the distribution lies with a peak value of 0. Okay, so you remember that standard normal distribution, the peak value here is 0. And the standard normal, so this is what we also call Z distribution. Yeah, and now the values on the x-axis, we denote them as Z value. This you see the value here, Z value. And we also call the distribution, instead of saying standard normal distribution, we also call Z distribution. It's the same. Okay. Now what we have to know about this kind of distribution, this one we have covered partially before, and you have covered it as well during your Form 5, right? You're at maths. So you have to know that the area under the curve must be 1, right? And it is divided into 2, right? So here, each of this is 0.5, and this is 0.5. The total is 1. So this one is, you have to know by yourself. Okay, it will not be given in the exam saying that the total area will be 1. You should know by yourself. Yeah, it should be 1. Because it's, the error is actually the probability. That's why it's the same thing like as I said before, the probability must be, maximum must be 1. It cannot be more than 1. Yeah. Every point must have a height that is at least 0. Okay, so means that here it should start with 0, the axis, the y-axis. Okay, right. So this is the formula that is used to transform any values into Z values. Yeah, this X values is the original whatever the data that you have. Yeah, from any normal distribution. So if you want to find, because the thing is, when we use the Z distribution, actually we want to find the table, we want to find the area under the curve. We want to use the Z table. So because it's under standard distribution, right? So we need to use the table. So that's why we need to transform any normal distribution into Z distribution by converting the X value to Z value. Okay, so only then you can use the Z table, basically like that. Okay, so this is the formula. The Z value is equal to X minus mu. Mu is the mean, and this is what we call sigma, or standard deviation. The name of the symbol is sigma. Sigma, and this is mu. I normally call the name of the symbol, but you should know what it means. Okay, so that's how you transform any X value into Z. And once you transform it into Z value, and only then you can use the Z table. Okay, so we have a very simple example here. Yeah, a person scored 70 on a test with a mean of 50 and a standard deviation of 10. Converting the test scores to Z scores and X of 17 would be, okay. So how, actually, this is the information given, right? 70 is X, yeah. The mean here is mu, 50. Standard deviation is 10, yeah. So if you want to convert it into Z value, yeah, so the X now become 2, isn't it? By using this formula. Okay, so that's how, I mean, it doesn't ask about the probability here, yeah, but this is just to convert Okay, but actually the reason why we want to use Z is because we want to convert to Z because we want to use the Z table to find the probability. Okay, now let's have a look at the Z table or the probabilities, the area under the curve. This is the Z table, you know this already, right? And what is given, there are many versions of Z table actually, but this is the one, I think this is the one that is used in the exam. So this version is only for one-sided, for the positive axis, or x-axis. So means that you just have to imagine the area from 0 to positive Z here, which means 0.5. The area under the curve here is 0.5. So if you see here, the table, the final value is given by 0.4999, which is equal to actually 0.5. Right. So the Z value is given by this first column. Okay, and this is actually the area in the table here is the area. This is area under the curve. Okay. Right. Let's go back to the lecture just now. Okay. So the situation that we use the Z table, we can use the Z table in order to find the area, given that we know what's the Z value. For example, in the problem or in the example before, we know the Z value and we can find the area. And it can be the other way around. That is, we want to find what is the Z value given the area. Okay, so that is meant here. The table can be used in two ways: to determine the area and also to determine the Z value. To determine area, to determine the Z value. It depends on the situation. Okay. Right. So if let's say find the probability of Z less than 0.45. So what does it mean? Right. So I would suggest you to sketch the thing so that you can see what you are looking for. So if let's say the Z is 0.45, you want to find the prop. When you say the prop, it's actually the area, remember? Okay. So the area of Z less than 0.45 is actually here, isn't it? This is 0 from Z0 to 0.45. So this is the area that you are looking for. And when you use the table, you have to know that the table, the way how you read the things, for example, given that Z equal to 1, so it gives you the area from the 0 value, means that, so if let's say 1, okay, if let's say you refer to Z equal to 1, for example, this is the value 0.3413. So this is actually 0.3413. So you have to know that that rule of this Z table, okay? Because in some cases you have to apply, you have to subtract the tail area. It depends on the situation, right? But the basic thing that you have to know how to use the table. So in this case, it's quite straightforward. So you just have to find from the table Z equal to 0.45, which is this one, isn't it? So this is 0.4, and this is the decimal point. So the value should be 0.1736. But you have to remember that this one is referring to only one side of the sorry, a bit like clumsy because I don't have the pencil, the Apple pencil with me. I'm using my finger. Right, this one. Okay, so this area given to you 0.1736 is just referring to the one side. So, but in reality, you have to also consider this negative axis here, right? Which you know that the total area is 0.5, right? Because when we say, I mean, this one is actually referring to the whole distribution. So when we talk about the distribution or the probability in the probability, we have to consider the whole distribution. We cannot just divide the distribution into half. Okay, so that's why we have to consider the negative axis over here. But it's just that the table, it just provides you with the values for the positive axis. But why it provides you with the positive axis only? Because the rule of thumb is that the Z distribution is symmetric, so you can apply it actually. Yeah, right. For this case, you can solve the values, right, for the probability less or equal to 0.45 is equal to 0.5 plus whatever the area that you got on the right side. Yeah? So this one is 0.5 and this is 0.1736. So it should be this one. Okay, it's not only 0.1736. Yeah. Okay, the reason is because we are talking about the whole distribution, and the whole distribution starts with 0. I mean with the earlier part. It's not just from the right side. Okay, so that's how you use the Z distribution table. Okay, so the rest is just practice lah. I think you can once you know the rule of thumb, then you can apply it. Like for example here, this is what I meant here. Find the prob of Z more than 1. So more than 1. Okay, so this is where you have to apply the tail area. So you cannot get it directly, yeah, from the table. Okay, so first you have to know that this is the area that you will get from the table, right? If you refer to the Z equal to 1, just now is 0.3413, right? So this area will give you 0.3413. But the question in this case is, you have to find the probability of Z more than 1. The area of the area of here, actually, this area. Yeah. So you have to use the tricks of 0.5 minus that 0.3413. You will get this area, isn't it? So the rest are quite logic lah. You have to know where you are looking for, what you are looking for, and from there you know what to find out. Okay. I don't have to go through that very thoroughly because I expect you guys have understood this. Yeah, like this one. Yeah? We wish to find the probability of Z less than -1. So that's why it's very important for you to sketch, so you know where it is. Yeah? If you don't sketch, you cannot visualize the things. Yeah? For example, here, -1. So it means that, of course, you cannot get it from the table because you don't have the minus, the values, but you know that it is symmetric. It is symmetric, right? So it means that actually the area here will also equal to the area if you sketch here, right? If you sketch here, when Z is equal to 1, right? So you have to find this area. Find this area in order to make it, in order to find this area, because it's the same. Yeah. So in order to find this area, you have to find what's this first, right? And then once you get this, let's say this is X, you have to subtract you have to subtract this from 0.5, and you get this area, and that will be the same as this one. Okay, right. Okay, any question on this? Because I expect you to know this by yourself. Yeah? I will not go through that very thoroughly. Okay, like this case is yeah, so the probability, whatever the things, the area that you are looking for, it can be various. It can be, for example, this one is in the form of range. So you have to know from what to what, and you just have to apply, let's say this one, and this is quite straightforward. Yeah? So this area is actually equal to this area, right? 1 is actually equal to 2. So you just get from the table for this and you multiply by 2 because it's the same, right? So it's given by this. This one dia tolak lah actually, but actually is if you got it like z equal to 1 is if you refer to the table just now, z equal to whatever, z equal to 1, right? Z equal to 3413. This is 0.3413. This is also 3413, right? It's actually times by 2. You got this one times 2. Okay? So I love this topic when I studied at maths during my high school, because it's something that is logic lah. It's something like quite logical, and you don't have to remember much as long as you understand the rule of thumb. Yeah? The 0.5 for each of that and what it means, how to use the Z table. Then you can solve any problems easily. Okay, this one, we wish to find the 93.7% percentile of the standard normal distribution. Okay, what does it mean? Here, it means that this is actually the area, and this is in terms of percentage. So if you convert it, it's actually 0.937. Okay, so what does that 0.937? It actually asks us to find what is the Z value first, and then what's the X value later. Okay, let's find what does 0.937 means. If I want to sketch it, yeah, it's actually here. You just think logically lah. So the total area is 1. So if it's 0.9, it's actually approaching 1. So suppose there is something that covers more than half, right? So this is actually 0.937, and actually you want to find what's the Z value. Yeah. So how you want to find it? You just divide it into 2, right? And we know that this is 0.5. So this area is supposed to be 0.937 minus 0.5, which is 0.437. Okay, right? Then you go to the table, find. Now you have to find from the inside to the outside, because now you have the value of the area, isn't it? So go to 0.437. What's the nearest value? You just get the nearest value. Okay, here you got 1.5. You got here. Yeah. So the Z value that you are looking for is 1.53. This one. 1.53. Okay. So this is the value. The Z here is. The Z here is. The Z here is 1.53. Okay. Right. What else? Okay, ni pun sama lah This one pun sama, 0.96. You sketch the things, right? 0.96 means it covers quite most of the distribution. Yeah. Okay. So we divide it into this is 0.5 and this is 0.9599 minus 0.5 equal to 0.45, right? 4599. Okay, so find from the table what's the Z value. It should be 1.75. Okay, right, so the rest I leave it to you. Yeah, some of the exercises here. Okay, let's have a look at this question. Given that the distribution of adolescent IQ scores is normal in shape with a mean of 100 and a standard deviation of 15 points. Okay, so what is the percentile rank of a child whose IQ is 120? Okay, so the first thing that you have to do is, this is actually the value that you are looking for, right? You have to convert it into Z value first. Yeah, z value first. So you have to use this formula. 120 is the x, the mu is the 100, standard deviation 15, right? You substitute into the formula, you get the z 1.3. So now you sketch on the graph, on the distribution. 1.3 should be somewhere on the right here, right? And the whole thing that is covered from the left hand, this is the area that you are actually looking for, the probability. Okay, so how to find that? You know that this is 0.5, isn't it? Then you just have to refer to the table. For z equal to 1.13, what is this area? So 1.3 from the table is 4032. 4032. 1.3 here, yeah. Okay, go back here. So here is 0.4032. Okay, so the total area will be 0.5 plus 0.4032, that is 0.9032, right? Or if you convert it into percentage, is 90.32%. Okay, because the question asks the percentile rank. You should convert it into percentage. Or if you make it round out it to 91st. Okay, the reason why it's 91st, not 90, is because it's already exceed 90 in this case. So it's actually like you just go for the next value lah, 90%. You just put 90.32, I can accept it. Yeah. Okay, so that's one example. So here, given that the distribution of adjacent is normal, it's the same thing like actually, but different situation and different areas that you are looking for. But this one is negative 0.67, right? So means you sketch it, so the area should be over here. Kan? It's actually quite senang juga this topic. This area kan. So this is the area. When you convert it into percentage, is 25%. Okay. Right. So one tips and tricks. Whenever you deal with the values of the area, yeah, from the table, please maintain it 4 decimal points, but you can round it up at the end. Okay, if you round it too early, especially when you have to find the tail area, then you have to subtract it from whatever 0.5. If you round up it too early, then it will be a bit deviated from the actual answer. Okay. Right. This one, the weight. So the rest is actually exercises. I've explained the important rule of thumb. Okay, perhaps you can look by yourself. Yeah, some of these examples. Yeah, it's just actually different situation. You have to understand the situation, the problems, in order to know what area you're looking for. You are not normally you're not just like looking for the area from 0 axis to whatever. Sometimes you have to find the axis, the tail area. Yeah. Okay. Right. So just keep some of the exercises. I leave it to you. Okay. I think this one is what I've explained as well. Oh, the answer. Any questions so far? This is also the same, but it's just that in the form of quite is in the form of proper problem for this. But how you want to tackle this problem is the same thing. Like this one is the mean. This is the mu, isn't it? Right? The standard deviation is this one. Okay. What is the probability? Means area. Means you use the table, the Z table, the fuel consumption is between this and this. Okay, so this is actually X, right? This is X. So you have to use, you have to transform it into Z using the X formula, right? Okay, so you have to solve it for both of the values, like 3000. 3000 minus mu is 3213 divided by mu is 180, and then for the 3005 is another Z value, okay, divided by 180 because it's two sides. So you will get Z1 and Z2, okay, and after that what you have to do is this is the values. I hope you get what I mean here. Yeah? So this is the values that you will get after you transform it into Z. Okay, and in order to understand what you're looking for, as I said, sketch the things. So it's actually between 1.18 and 1.59. So this is the area that you are looking for. So how you want to find this? Yeah, you solve it accordingly for this one. Find first the value of this area, yeah, and for the 1.18, you have to imagine that if you have here 1.18, it will be the same with positive 1.18, right? So the area will be similar with this, and you add up the two values, you will get this value. Okay. Yeah. So the second question is x less than 3000 means is actually, any questions so far? So means that 1.18, negative 1.18. So it's here, isn't it? So this is the area that is one. So how you want to find it? You have to apply the symmetry rule. You have to find the area from here where it is 1.18 because it will be equal to this, right? So it is 0.119 if you refer to the table, right? And if the last question, x greater than 3500, it means what? It means the area when it is more than 1.59, when x is equal to 1, more than 1.59. So this is the area. Okay. So once you understand the rule of thumb of Z distribution, it's easy for you to solve any kind of situation. Yeah. Okay. So here. So this is just for your information actually. When we talk about normal distribution, yeah, the mean value has been set at 0, isn't it? Right? And when you have like plus minus 1, is actually this one is referring to the whole area here is actually 68%. Yeah. So when you have more than that, standard deviation with 2, I mean the area is bigger, isn't it? It's from here to here. So it covers actually 95%. So this is just information, just for your information. Okay, what else? Same thing. Okay, so this I think this is the more important. Approximating the binomial with the normal. Okay, so whenever we have the binomial data, yeah, we can actually use normal distribution, provided that it should satisfy these two situations. Okay. When you multiply the n with the p, it should be more than 5. And also when you multiply n times q, q is 1 minus p. Okay. Q here is referring to 1 minus p. Okay, whenever you got the p value like 0.3, The Q is 1 minus 0.3, which is 0.7. Okay, so 1 minus P is equal to Q. So the multiplication value should be more than 5, and only then you can approximate the binomial data with the normal distribution. Okay, so if these two conditions are satisfied, then you can proceed with the normal distribution, and you can use this formula in order to find the lambda or the mean. The mu, sorry. The mean, n times by p, and the standard deviation is the square root of n times p times q, because you need these two values in order to use the z table, right? So that's why you have to find this. Okay. And then another thing that you have to also do is that you have to do some sort of continuity correction. So what is meant by that? You have to, for example, you have to subtract 0.5 from the lowest number. I mean, if let's say you have a range, you have to subtract 0.5 from the lowest value, and you have to add 0.5 to the right value. Okay, so that's the thing that we have to do. We cannot apply directly. For example, just now we have the z between let's say from 1.5, let's say, and then this one is 2. Okay, so here this is you have to do this continuity correction by subtract 0.5. So you shouldn't use the value of 1.5 actually, but you should use 1.0, and this one you should use 2.5. Okay, this is only for a case where you approximate the binomial data to normal distribution. But if let's say it is not something related to binomial data, like the case before, like when we solved the problems before, we don't have to add or minus 0.5. Okay, so this is just for this situation when you approximate the binomial with the normal, and you have to make sure these two conditions are met. Yeah, these two conditions, then you proceed with this, and then you proceed with this thing. Okay, plus minus 0.5 and plus 0.5. Okay, right. For example, let's have a look at one problem before we wrap up. Yeah, I think this is the last slide, maybe the last two slides. Okay, this is an example of a problem where we approximate this binomial data to normal distribution. Okay, from years of observation, biologists know that the probability for any given Arctic tern to survive the migration to its winter feeding ground is only 0.65. A random survey banded 500 Arctic tern. Okay, so the information given to us is this. The prop of survival is 0.65. Okay, P is equal to 0.65, and then 500. This 500 is n. Yeah? N equal to 500. Okay, so in order for you to know whether it is possible or not to use normal distribution, you have to check two things, right? NP and NQ. It should be more than 5. Remember, the things that we have to match with is more than 5. Yeah. NP and NQ should be more than 5. Okay, let's have a look at the problem just now. So now the P is 0.65. So Q should be 1 minus 0.65, that is 0.35. Yeah. Why 1 is because probability is 1, the total. Right, so NP is equal to 0.65 times 500, which is 325. Yeah. Okay, so it is more than 5, isn't it? And then we have to check the second situation, the second condition, which is Q. Q is 0.35 multiplied by 500. It is given by 175, which is also more than 5. So both of these conditions are met, so means that we can use the normal distribution. Okay, so what next? So what else we have to do? Okay, now it's given that use the normal approximation to the binomial to find the probability that 310 and 340 will survive the migration. Okay, so we have to find first what's the mu, because we don't have the mu value. Okay, so if you refer to the notes before, okay, this is the thing that you have to solve. Yeah, so the mu equal to n times p, and the standard deviation, the sigma, is equal to the square root of n p and q, n times p times q. Okay, so we solve for that. We solve that, right? So np is equal to 325, right? And the sigma, the standard deviation, the square root of np cubed, is given by 10.67. Okay, so that's the mu and the sigma value. So now we can solve for the z value. Don't forget to convert the value of 310 and 340 to z value. Okay. Right. So next is to change, to convert the values to z value. Okay. Remember that we have to do the continuity correction, whereby we have to subtract 0.5 from the lowest value and add 0.5 to the right value. Okay, so this is what is meant by that. The actual value is 310 and 340 given in the question. So we subtract 0.5 from 310, that's 309.5. And for the right value, 340 plus 0.5, okay, that's the value, okay, that you have to use in the Z formula. This is actually the Z formula. This is the Z formula. But since we have this range, we have to solve the Z values for both of it. Yeah. So this is actually mu. This is the standard deviation that you have solved previously. Okay. So when you solve these two values, you got minus 1.45 and 1.45, right? We are not done yet. This is only the Z value. Now we need to find what is the distribution, what is the probability, right? And we have to sketch the things. This is 1.45 minus 1.45. This is 1.45, the Z, right? And this is actually the area that you are looking for. Yeah. Since the value is the same, right? 1.45. So you can just find the area of the right side, right? And you just multiply by 2. This is a bit, I think this workout here, don't refer to this, it's a bit confusing. What you have to do is, like, you have to find what's this area. What's the, let's say name it as B, right? This is A, right? So the B area is when Z equal to 1.45. 1.45 is here, 4265, right? 4265. So this is 0.4265, and we know that is symmetric. This is also 0.4265. You just multiply by 2, then you will get this value. Yeah, 4265 times 2 is 0.853. Is it correct? Workout ni ada, it's a bit confusing. You just apply what I tell you here. I teach you here. 6.5 times 2. Yeah, 0.853. Okay. Don't refer to this. It's actually correct, but it's a bit confusing. It's more straightforward if you just find from the right side and then you multiply by 2, because this one is the same value, so you can just multiply by 2. Yeah? So that is the probability. This is the probability. Oh, this is the probability that you are looking for. Okay, and see, it is less than 1, right? So it's valid lah. Okay, I think that's it. Any question here? So basically, in this second lecture, we cover normal distribution. Yeah, normal distribution. Um, so we talk about what are the properties of normal distribution, right? And then we move to standard normal distribution. Standard means when the peak value is 0. Yeah. So and this refers to the table actually. Yeah. And then what else? Probabilities, how to use the Z table, how to find the probabilities, the Z values, and so on, right? And then the last part is how to approximate the binomial distribution with the normal. Okay, so there are conditions that you have to make sure to be met, right? And only then you can proceed with the normal distribution, which is NP times NP should be more than 5, and Q should be more than 5. Yeah, that's the thing that you have to check first. Huh? Okay. And in the first lecture, we talk about Poisson and binomial distribution, isn't it? Okay, just go back what we have learned before in the first lecture. So we talk about binomial distribution and Poisson distribution. Yeah? So we talk about discrete. Discrete is actually binomial and Poisson are discrete distribution. Yeah? So just now normal distribution is under continuous distribution. Okay. But before that, we also have observed distribution. Observed distribution is something that just directly from the data and calculate, like probability. We don't refer to the table. Standard distribution, we refer to the table in order to get the values and to find the area. The area is actually the probability. Okay. I think that's it for today. I will, I don't have time for the class activity. I will put include the activity in the Telegram, right? Because I have to go now. Right. So that's it for today. Thank you very much for your attention. Any question? Please let me know. Or if I can't answer now, you can email me. Okay? And for the attendance, siapa yang tak ni? Penny. Okay, manual attendance, yeah. Only Penny? Okay. Alright, yeah, that's it. Yeah. Thank you. I'll see you guys next week, inshallah.
Thank you, Doctor.
Right, have a nice day. Stay safe.